Hello. In this part we'll look at running of the 68 kV board, and I'll try to cover a few of the components like parts needed to make it work, and how you make connections to the board, the serial setup, the communications to the computer, running the monitor on the actual on the serial terminal program, and using some of the monitor commands within that program, and then trying out a simple machine code example, saving the code on the PC and loading it back into the board. So let's look at the board in a bit more detail. So here's a picture of a fully constructed board. As you can see, there's the CPU, the UARTs, the two NVRAM chips, and the two GAL chips, clock chips, and for example this terminal connection here for the links. These two pins are linked, and so are these two. You make your power connection on this block terminal here, and your primary or serial terminal connection here. One of the mods that I mentioned is from one of the GAL chips, I think GAL 2 chip pin 3 to pin 18 of the GAL 1 chip. It's to do with that LDS line. And then what do you need to run the actual board? Well, you need a terminal program. You obviously need a power supply to power up the board. This is not the actual one I use, but it just gives you a picture of one. The reason I show you one of these is that you can sort of monitor the voltage and also the current that the board is acquiring. It's sort of important because if things go wrong, at least you can tell straight away that you should not really continue anymore and turn it off and check what is going on. Then you also need a TTL to USB connecting cable. Usually one of these 4-pin ones are okay, where you just got RX, TX and power and ground, although we don't use power or the +5 out of the USB connection here. And the terminal program that is used is the real term. I mean, you can use any other ones, but I'll just give you an example of the one I use, which is that one, and you can download it from this website and just follow the instructions and whatever, and you should be able to run it out. The next part is the connection of the power supply, which the two wires like the +5 and ground, and also connection to the USB cable. As you can see, the coloured wires are green to the RX and white to the TX, and if you notice the actual colorings here, say they're the opposite way. They're the connections to the computer, and this is connections to the board. And when the board is running, for example, if you run at about 5.177 volts, it should draw about more than 500 milliamps. So that's a good indicator that everything should be okay. Now also notice that this example, because I'm using the 68681 monitor connection, I'm not using the 6850 chip, so I've taken it out because it's not fully decoded with the GAL chips. It's best not to have that chip on the board when you're doing this part of the test of the monitor. Now once you power up the board, what you'll get is through on the terminal software, you have to set it up, for example, to be odd parity, 7 and 8 bits, 2 stop bits, no hardware handshake. The correct USB port, it might not be 4 on yours, whatever the USB to TTL converter shows you up in this part here. It might be a different number, and 9600 board. You also in this part here have to probably select the ANSI or ASCII type display. So if everything is okay and it starts up, it will come up with monitor 68K version 5.0 with the arrow pointing. That's all you get, and it indicates straight away that the monitor is running okay. And if you type in, for example, command H, it will give you this help command, which gives you the breakdown of the commands that you can use for this monitor. I'll go through some of these, not all of them, just to give you an example of how the thing works. For example, we'll use the go command, which is basically executing part of the program. The help, which you already sort of can see here. Load an S record from the PC into the memory of the board. Do a memory dump from the board to the PC. Memory modify, where you individually go and look at some of the address or some of the data address lines and change the values of the data on those address lines. Register dump, and what else? Maybe upload the S record again and maybe modify the register to particular value. So as you can see, that's how the monitor works. It's sort of it gets command and then executes it and then gives you the prompt again. Hi, in this part we show the running of the board. As you can see, here's the picture of the board connected to the power supply, the terminal program set to ANSI, scrolling screen, 9600 board, 7 bits, 2 stop bits, no parity, no hardware control. Put it on and there is the prompt. So now if you type in H for help, it should come up with all the commands that it does. So for an example, let's have a look at a program that I've looked before, which is basically adding 3 numbers together, and this was compiled using Easy68K editor that you should be able to find on the web. And basically what it does is creates a program at address 8000 and loads the first, I'll just minimize this, the first word into register D0, adds the second one in D0 from the second address location, which is located at 9001, 9002, and then it adds the third one and puts the whole lot back in address 9006. So to try out the actual monitor, we just manually enter these data bytes into the memory starting at 8000 and enter the raw numbers at 9000. So let's do that. So going back to the monitor, we got memory modify 8000 and press return. As you can see, it's FF, so going 30, press return, then 39, press return, and so on. I'll stop at this point till I enter the whole lot of code in there. Okay, I entered all the data, like all this program data here and the actual values for the numbers there. So we can do like a memory dump of the, I'll do help again. So memory dump, so MD, and I think you need to give it a starting address, say 8000, and probably how many bytes or something, so 20, and it comes back with these numbers, as you can see. So we go 3039 0090 D0 whatever, so on and so on. And it goes up to this point, which should be okay. In the same way, we can have a look at the 9000 location. I'll just do a 10 on this one, and you can see that the numbers there are 1 2 3 4 1 2 3 4. Remember, these are hex numbers, and the result is set to 0. So now if you want to execute this program, you just type in go, I think it's go, yeah, go and the address, G-O, and then the address which should be 8000. And it comes back to the monitor because we got that trap 14, which is returned back to the monitor command. So now if you look at the memory dump of the 9000 location, it should have the result in this area here instead of 00. So let's do that again. And look at that, it's got 369C, and just to check that it's correct, let's do a hex calculation. I'll clear it again. 1, 2, 3, 4 plus 1, 2, 3, 4 plus 1, 2, 3, 4 equals, and there it is, 369C, which is exactly the same number there. So it's working okay. Alright, I'll do a memory dump of the 8000 location and on and just see what is there. Memory dump 8000 space 20. Right, so it's filled some sort of data in there. So we haven't got the program there as it was before. In the same way, let's have a look at the 9000 location. And it's also filled with 2 zeros. It's load. So load, and return. And all you do is enter file to transmit on host. So just send file. And it's done, and you go stop, and then you go return. Control Z. Now if we do a memory dump of the 8000 location, let's see if the program is there. And look at that, it's there. Let's do the memory dump of 9000. Let's see what is there. And in the same sort of way, it's loaded the 1, 2, 3, 4, 1, 2, 3, 4, the 3 numbers and the 0 result. So now if we tell it to go 8000 I should say, now look at the dump of the memory 9000 and see what is there. Didn't do the go execution properly, so let's do that again. Go 8000 memory dump 9010, and there it is, it's working fine. In the same way that you uploaded the S file, you can also download it into the PC. And yeah, it's actually this one here, upload the S record into the PC. So let's try that. Okay, to upload the file to the PC, use the command up start and end. So you from a certain address to ending address. And then you have to use, I think, Control-C to terminate. So let's just do that. Okay, let's try again. We'll do the memory dump from, say, 8000, 20 bytes. And most of the data is there. So now let's upload that to the PC, so 8000 to 8020, and see what happens. Right, so this is ready to send, so I have to put the, and this is my capture file here, so I go start overwrite, and then Control J, to upload complete, and then Control-C to terminate. So it's already finished that. So let's go and have a look at that file, see how it looks like. Okay, there is the file there. So as you can see, it's captured everything, including the message from the terminal saying upload complete. So you can actually delete all this up to this point here, and that should be okay. And then just resave that file, and then you should be able to load that as like a normal S-record file back into your monitor program and run it on the board. And there you are. As you can see, this monitor runs okay, and it gives you all the other commands like registers. Let's do register dump. So you can see all the registers dump. You can actually modify the registers, I think. So dot R to value FF. See what happens. Register dump. So I don't know where that FF went to, but it should do. Oh, maybe you need dot particular naming. For example, dot D1, dot D0, for example, equal to 8 blocks of zeros. 1, 2, 3, 4, 5, 6, 7, 8. And then return, and if we do register dump, there it is, it's changed. So that's how that one works. Great, and that shows you the example of the board running with the monitor. Alright.